This video is about geometry with a focus on angles and parallel lines. Here I have two parallel lines. I also have a line that cuts through these two parallel lines. A line like this is called a transversal. You can see that by drawing in the transversal in this case, I've created 1, 2, 3, 4, 5, 6, 7, 8 angles. And some of these angles are equal in size. These two angles marked in green are the same size. Notice how they are between the parallel lines, but on opposite sides of the transversal. Angles like this are called alternate angles, and alternate angles are equal. There's a second pair of alternate angles in this diagram. Can you find them? The angles shaded in yellow are also alternate angles. Again, they are between the parallel lines and on opposite sides of the transversal. This rule can be useful to help me find unknown angles in a question. For example, here I have a pair of parallel lines with a transversal drawn through them. I'm told that this angle is 50, and I want to find the size of the angle A. What do you think A would be equal to? A equals 50 degrees. Like in previous videos, if I don't need to do a calculation, I should reference the rule that I'm using. And the rule here is alternate angles. Here's a second unknown angle, the angle B. I want to find its size. Rules that we've encountered previously still apply. What's the name of the rule that allows you to work out B once you know A? You might notice that B and A are supplementary angles. So once I know A, I can simply subtract it from 180 to find B. And the result is 130 degrees. It's important to know the name of the rule that we've used, supplementary angles, but since we've done a calculation, the calculation will suffice to explain our result. Remember that even though we will continue to add new rules to our list of available rules in geometry, rules that we have encountered before still apply. We can still use them if needs be. Okay, let's look at the next rule. So again, we have a pair of parallel lines, and again, they're being cut by a transversal. We've already looked at alternate angles, but there are other rules that allow us to match up other pairs of angles in this diagram. For example, these two angles shaded in orange are equal in size. Notice that they're in the same relative position. Top left of this portion of the diagram, top left of this portion of the diagram. These are called corresponding angles, and there are quite a few of them in any diagram like this. Take a moment to see if you can identify any other pairs of corresponding angles in this diagram. These two angles shaded in green are also corresponding angles. Can you see them anywhere else? The angles shaded in yellow are also corresponding angles. They're equal in size. And the last pair are pretty obvious. The angles shaded in blue are also corresponding angles. So here's an example. In this diagram, our parallel lines are running this direction, and here's our transversal. I've marked in the angle 80. Would you be able to identify which angle or which position the corresponding angle to that 80 should go? This angle A is the corresponding angle to 80. How big is A? A equals to 80. Corresponding angles are equal. Here's another angle, the angle B. Take a moment to try and work out the size of the angle B. You might notice that 80 and B are supplementary angles. They make up a straight angle. So we can calculate the size of B quite easily. It's 100 degrees. Here's an angle C. Could you calculate the value of this angle? Possibly the easiest way to calculate C in this case is to notice that it is the corresponding angle to B, and so they must be equal in size. Of course, when calculating C, I would also have the option of noting that it was a supplementary angle with the angle A. Either option will give you the same result of 100 degrees. Here I've marked in the angle D. Take a moment to work out the size of the angle D yourself. There are a number of ways that we can go about this. You might notice that B and D together are supplementary angles, so I could subtract B from 180. There's a slightly quicker way using an earlier rule from a previous video. Do you see it? And can you remember the name? D and 80 are directly across from each other. These are called vertically opposite angles. We know that vertically opposite angles are equal, so D is equal to 80. Again, if I don't use a calculation, it's a good idea to reference the rule. And lastly, here's the angle E. Can you identify which other angle in the diagram is the corresponding angle for E? D and E are corresponding angles. This means that I know they must be the same size.